I haven't filled in the markings on the diagram. Right. Explain. So for G, if we're going in alphabetical order, right? This angle is between the tangent and chord. Oh, it's actually that 60-degree angle there is between the tangent and the chord, right? And this chord also contains angle G. So that means that angle G is going to be 60 degrees because of tan chord theorem, right? Then to get H, guys, now we see that G is at the circumference. H is dependent by that same chord, but it's at the center, right? So H is going to have to be, if G is 60, H is going to be double that, right? Remember the angle at the center is always double the angle at the circumference. So H is going to be 120. And then for I, do we agree that this is a radius, right? And we know that a radius is always perpendicular to a tangent. So this whole angle is supposed to be a 90-degree angle. So if that part is 60, then I has to be 50 degrees. Right, because I and 50 degrees together should equal 90. So you don't have to show that calculation there. Because I said I equals 50 from the start. But you have to have your reasons handled, right? So you have to have it. Yeah. So you're going to say I is 180 minus 120 over 2, and the other triangle, and the country. That's all. Okay, any other questions on number 4, guys? All right, for number 5, J and then K and then L. So for J, I use tan chord theorem. I think it was a bit more difficult in this case, but you have that 40-degree angle there, which is between the tangent and this chord, and then this chord subtends angle J as well, right? So because of tan chord theorem, J and that 40-degree angle have to be equal, so J is going to be 40 because of tan chord theorem. Then guys, I just follow the alphabet there to get K. I did my tangent perpendicular radius thing again, right? Because now this is the diameter. So we're going to say tangent perpendicular diameter as well, but that part of the diameter is a radius, so it doesn't really matter. But this is a radius diameter, right? And we know that it's always perpendicular to the tangent. So K and 40 degrees together should be 90. So that means that K is going to be 50 degrees. Because the tangent perpendicular radius, or if you're a tangent perpendicular diameter, that's also fine. And then to find L, guys, you could have done angle sum and triangle if you wanted to, that's fine. It would have gotten you the correct answer, right? Because if you have that 40 and that 50, you can say 180 minus 40 minus 50 will give you 90. But also, do we remember that this is a diameter because it's going through the center, right? And a diameter always subtends a 90-degree angle at the circumference. You can see that my reason for that was angle and semicircle, but you also could have done angle sum and triangle for that. Yes.
Are you I think we
So you were supposed to do it in alphabetical order, but if they don't say it, then that's fine. Okay. All right. Any other questions on 5? Let's look at 6. No, sorry, I have to put it there on the side. This is why my reasons are like cut off. So for 6, again, if we're going alphabetical order, sorry, I keep fumbling over my words today. So that is the one that we said yesterday, 38, right? Not very clear there, but that's 38 degrees. Again, guys, tangent perpendicular to radius. That whole angle should be 90. So M is going to be 90 minus 58. Okay, so M is 52 degrees. You see, it does actually come up quite often, right? In this worksheet, but also just in general, when you're gonna go back to the textbook. The whole tangent perpendicular to radius thing is quite a common thing. Then also because of tan chord theorem, guys, if we're looking at this 38-degree angle, right? Is the angle between the tangent and this chord. But then this chord also subtends angle A. But it also subtends angle P, right? So you actually could have used tan chord theorem for N and for P, right? What I did was I said N is 38 because of tan chord theorem, and then I said angle in same segment for P. But you could have used tan chord for N and P, right? That also would have been fine. So if you wrote N equals 38 and P equals 38 degrees, tan chord theorem, that's fine. All right? All right, final last one, guys. Now, 7, there we go. I just asked you to label that point there as C. Now, to get R, I did something that you might not have done, so you can try it on that. You might have done angles on a straight line and then angles on a triangle, which is perfect. So I'll just add that to the bottom. But guys, in order to find Q for this one, you actually have to do like an in-between step, right? If we're just looking at that 50-degree angle there and the Q, there's no way that I could find, I don't know, maybe one of you found a way of going straight from this 50 to that Q, right? So what I did was, yeah, there was something else we also could have done. Yeah, so these are radius, correct, yeah. So because those are radii, you could have said that that is 50, correct? We'll fill that in. Tan the particular radius, yes. Not tan chord in this case, because you could have calculated that angle. Yes. Okay, so you might have done that, yeah. So that's 50 and that's 50, then this angle is going to be 80. But because this is at the center, that one will have to be 40. Okay, so because of that. So you could have done that. That one would have to be 40, and then this one is 80. But what I did, guys, and I should have asked you to label that point as well. I didn't think of that today. Then the layout would have been a bit easier. But are we all fine with that angle being 50? Right? Because of angles up to equal sides, radial. Okay. So I put my reason for that over here. You underline that in blue. Those are the reasons for me using this 50 degrees here. And then, like you were saying, this is a 90-degree angle because of tan perpendicular radius. Okay, so I just wrote there OCA is 90 degrees, tan perpendicular radius. So your layout might have been a little bit different. You might have just gone straight to, what is happening? You might have just gone straight to calculating Q, but then you have to have all three of these reasons to that calculation. Okay, so this is 50 degrees because of angles of the equal side. That is 90 degrees because of tan perpendicular radius. So that means that Q must be 40. Okay, because it's 90 minus 50 is 40 degrees. All right? Or, I don't know, what you would have had to do is you would have had to say that this is 50, angles of equal sides radii. That one is 80, angle time and triangle. And then Q is 40, tan chord and angle. Okay, so you would have to have quite a lot of reasons for that. So that's Q. Q is then 40 degrees. Now to get R, I think you probably would have done angle on straight line there, right? To get this angle. Now, unfortunately, because I didn't think to label this one, I don't know what you would have called that. But this is 150, right? So you agree with that? Oh, sorry. That angle over there is 150, and then you can use angle sine and triangle. But guys, next time remember exterior angle of the triangle. That can save you some time. So we agree that this 50-degree angle is actually an exterior angle of this bottom side. Right? Because it's the side of the triangle that's been moved. And we remember that the exterior angle of the triangle is always the sum of the opposite interior. So this 40-degree angle and R should add up to 50. Right, so R has to be 20 degrees. So that's So what I did was I said the exterior angle, 50, minus the interior one that I have. Alright, minus 50. And that's going to get in between. Okay, if you did angles up or angles on a straight line and then angles on a triangle, you also would have got an R. Yes.
Two opposite things there.
Added. Yeah. Alright, any other questions on number 7? Okay, for number 8. I did quite a lot of writing for this one. And also I couldn't find them in alphabetical order. Was anyone able to find the expert? I don't know if I was just being silly. What did you do to find it? Oh, yes. Okay, no, I don't know why I didn't think it was that. So that one again is 55. Okay, 55 degrees. So I'll write that down now. So what's that? OCD. I did write that. And then I just didn't use it. Okay, weird. I'll fix that now. So angle OCD is 55, yes, and then tangent is the radius. Weird, I don't know why I didn't think to do that. Alright, so then 8 is 55 degrees. Okay, because of that. Okay, so let me quickly fix my order here. We'll just use this, then everything else might also be different. Alright, so S is 35, and I'm going to change my reason for S to tan perpendicular radius. Okay, right? Tan perpendicular radius. Okay, then next up you would have to find T. So now my working for T is also going to be different, probably. What can we do to find T now? So we use exterior angle on the triangle there, right? Like we just did in the previous question. Again, this 55-degree angle is the exterior angle of this bottom triangle, right? So these two angles together should add up to 55. So what must T be? 35 plus what will give me 55? 20, hey. Or if you can't think of it that way, you just take the exterior angle and you minus the interior angle that you have. So 55 minus 35, and that will then give you 30 for angle T. And so that is what I did to get T. Let me just move that up. I did exterior angle of triangle to get T. Alright, just again, 55 degrees is the exterior angle there. So you can minus the interior angle that you have to get the other interior. So 55 minus 35 is 50. And then you can just 35 because of tan 4, okay? So if you have this 35-degree angle here, that is between the tangent and chord CD, and CD then subtends angle U. Alright, so U is just 35 degrees because of tan chord there. You didn't need to do all these extra calculations. So that reason is here. Are you guys getting off this one? Like I said, we have a week to just keep practicing. So hopefully by the end of the week. Yeah, good luck. And then you will have to talk to them. CODH, which is 7 group. But I see and I see yeah, to get it. Okay. We'll have 4 tomorrow, okay? 9 as well. Okay, so again, for number 9, I wrote quite a lot, because more the reasons were quite long. All right, so here we had to find V first and then W. Right? So if we're looking at, and they also just told us here, because they said in the heading of the whole exercise that VA is a tangent, now they're saying that AC is also a tangent, right? So guys, like we said yesterday, if these two tangents are both coming from the same point outside the circle, then those two tangents are equal to each other, right? Do we remember that? So this angle here, which is actually 68 degrees, is going to be equal to that angle there because this is an isosceles. Right? That's the last note or the last part of the note that we wrote here. So I calculated that first, right? I said that angle AEB, so that whole angle there is equal to this whole angle, right? Which is 36 plus 33, which is 68 degrees. Okay, my reason for that was angle opposite equal sign. That's the isosceles triangle reason. But then again, how did I know that these two sides were equal? And from common point. Okay, so instead of radii, which is what we normally write, to say that the sides are equal, we have to say tangents from common points. And then I used angle, sum, and triangle in that big triangle to calculate these, because I had 68 and 68, so I'm subtracting both of them from 180. We will show you here this triangle. Right, V is that top angle, so I said 180 minus that one to get V. Okay, this is 44. Did anyone get V in a difference? Alright, I just quickly need to tell you how I got W, then I'll come back to the answer. So now we have that V is 44, and we have that that is 68. And what did I do to get W? So this one is 36. And chord there. Oh, can chord, yes. Here, this 32-degree angle. This is a difficult angle here, one. Right? This angle 32 is between the tangent and this chord, right? And this chord subtains that angle over there as well. You see? So this is 32. This one here. No, no, I'm talking about just this bottom part, just this one. Yeah. Alright. You don't have to. Do we see that time chord there, guys? It's a difficult one to see because it's so like to this side. But this is the angle between the tangent and the chord, right? So there is 132. And that same chord then subtends that angle. Right? The inner angle there. So this one is also 52 degrees. And then I use the angle from a triangle from there. So then I say W is going to be 180 minus 36 minus 32. Yeah, that was a hard one. So guys, again, sorry, my bad, because we just say, well, this point here, I wasn't able to first say that this angle is okay, right? If I had made this like an X, for example, then I would have said angle DEX is 32 degrees because of tan angle. And then in a separate line, I would have said the angle from the triangle, but I forgot to label this one. Okay. So I put both of those reasons in one line. The tan chord theorem is explaining why that angle on the inside of that triangle was 32. No, that's only Next, so you must go to the library, you must take out, no one's gonna be allowed to be like, oh, there's a library. I was thinking, I'm not Christian, I just like to go, I don't know. Supposed to be silent, no problem. They let you off. Or they might say you can go sit out on the field or I don't know, how to call it. Okay, I'll find it up one guys. For today, we'll have to get more playing for me. Ned. Okay, number 10. Number 10 wasn't that bad, right? For number 10, you had these two chords that are equal. So those two angles are equal, right? Because those equal chords equal angles. We find that one. And then after that, I use tan chord theorem for both of them. So y, right, is the angle between this tangent and this chord subtends x, which we said was 26, right? So y is 26 at 4. And then if you're looking at z, which is on this side, z is between the tangent and this chord subtends that 26-degree angle as well. And so y and z will also both equal to 26. Any questions? Okay, let's look at 11. 11 was a little bit longer, but not that much harder, I don't think. You did have to do like an in-between section in order to get A, right? We can't use tan perpendicular radius for this one, right? Do you agree? They didn't give us a radius here. They didn't even show us where to say it. Okay. So I looked at the fact that this is an isosceles triangle. They showed us that these two are equal. So that means that if this angle is A, that one will have to be A, right? So that one is equal to A. So you do it. Oh, wait, I actually did it slightly differently. Let me fix that. I first looked at tan chord theorem. Then, right? And we agree because of tan chord that angle C will be 80. Right? But then, like I just said, because it is an isosceles triangle, that angle is also equal to these two angles are equal to each other, right? Because in the isosceles triangle, the angles opposite the equal triangle is equal. So if that angle is 80, this one also has to be 80. Right, because of angles opposite equal sides. So therefore A is 80 degrees, okay? And then I just did angles on a triangle to get these. Okay, because we have that is 80, that is 80. So you can do 180 minus those two, and that will give you that B is a 20. Okay, if your layout is a little bit different, right? But you do have to have all three of these reasons. So we want to do this one in a different. Okay, last one. This one was interesting. It didn't give us any values, right? But we had to work on what they gave us there. So, right, because they didn't give us any values, we have to like introduce a value somehow, right? Otherwise we can't solve it. So what I did was I noticed that, okay, we have a triangle here, and I know that the three angles of the triangle add up to 180. So I thought I would use that, right? If I have all three angles of this triangle, then I can add them all up to and say that they should equal 180, and then I can solve it. All right, so I have that this one is 6C and that one is 7C. I'm trying to find this angle over here, and then I'm trying to find that angle over there so that I can add the three angles together and get 180. Okay, so first I said that if we're using tan chord, that 7C angle is between the tangent and the chord. And this chord also contains angle C, right? So that angle is 7C because of tan chord here. Yes? Then I also have a Z shape here. And because they told me that these lines are parallel, remember guys, if you see that you have parallel lines, that's a hint that you have to look for those shapes, right? Z shape or X shape or C or U shape. So I look for my Z shape and now I see that this 7C is actually also going to be equal to that one, angle D, because of alternate angles, right? So this one is also 7C, yeah, so this is actually an isosceles triangle. Alright, so that one is also 7C. But now what that gives me, guys, is 3 angles in a triangle. And we know that the 3 angles of a triangle should equal 180 when you add them together. Alright, so once you have that C is 7C because of tan chord theorem, and D is also 7C because of alternate angles, then you can take those 3 angles in the triangle, add them up equal to 180. You'll read them as an angle sum in triangle. Here we have 7 plus 7, which is 14, plus 6 is 26. And then you can see you have to say 180 divided by 3. Okay, so that was an interesting one, guys. They didn't give you any value, so you need to look for a value somehow. Right, in this case, we had to do angle sum and triangle. Have 180. Okay, you are going to do the rest of that worksheet now, which is 13 to 21. It is on the back of the page. Right, I did label some points yesterday. I'm just going to quickly double check that we have actually labeled everything that we might need. Yeah, I think we're fine for labels. The other one. All right, so you're doing all of them, guys. Between 19 to 21 on all of the page 7. They're all labeled in yesterday. You have half an hour left to see if you can finish it. Yep.